So another design mistake we see designers make is not respecting the maximum inverter output on the battery inverter. So if you put more load onto the battery than what the inverter can handle, it's going to turn off. You know, it's going to enact its own safety precautions. So if you try to overload a battery inverter, you can insert reliability issues into the equation. So we need a better understanding of how battery inverters actually work. So a solar inverter is one way. You know, it takes the power from the solar energy and dumps it out the inverter. A battery inverter is two ways. You know, it can charge and discharge the battery. And so a battery inverter by nature is more complicated than a solar inverter, and it's going to be more expensive than a solar inverter because it does more things. You know, there's two sides to the battery inverter as well in most battery inverters. This can change based on the system architecture. But there's a grid side, and this is a synchronous side. You know, this side of the inverter outputs to the grid. It synchronizes to the grid. But remember, it's synchronous. So if the grid goes out, guess what? You know, that side of the inverter goes out too. The backup side of the inverter, therefore, is asynchronous. And what that means is the load running on the asynchronous side, you know, regardless of the mode of operation of the inverter, whether the grid's up or grid's down, you know, you don't lose power to that backup side of the inverter. But, you know, this is an 8 kilowatt inverter, you know, in our example. So what happens is if you exceed 8 kilowatts on the backup side of the inverter turns off, and that protects all your non-critical loads that are grid tied, but all your loads on your critical load can turn off if you exceed the rating of the inverter. Then again, you're doing the opposite of, you know, what you're supposed to be doing, which is improving grid reliability. Now you're taking it off. So, you know, you have to make sure that your inverter is large enough to handle all of your coincident loads. Otherwise, it's going to drop power. And you know, National Electric Code, for that matter, says, you know, your standby power sources need to be capable of powering the entire intended load.